analyzer. Okay, there's a thin shell, thin charge shell where charge is present here. I really want you to think. What will happen to this shell? Will it expand or contract? Thin. Thin iron shell. Okay, no, carry on. No. So it is carrying a charge Q. Will it expand or contract? If it expands, how it will expand? We should give reason. You can't just say, sir, expands. So what is actually again? So this is similar to like a the charge present here. What it will do? It will produce field on either side. No. So I'll give name 1, 2, 3, 4. Charge present on one will produce field on either side. E bar, E bar. It has to be. Charge present here will produce field. E3 and E4. Now, why field inside the conductor 0? Because these two are equal and opposite. That's why it is 0. I think I'm giving very good explanation there. I forced you using Gauss law. Okay, what is again expression for electric field? E1, E2, E3 equal to E4. Here also same sigma by 2 epsilon naught. But we don't know sigma. What is sigma here? Sigma is Q by 4 pi R square because where charge is present on the surface of a thin conducting shell of radius capital R. In fact, here, so why field strength at point 2 is 0? Yes, the field strength at point 2 is 0 because E2 bar minus E3 bar. Now, what is the field strength? Just outside the here. So somewhere here, just somewhere here, near to the shell. It should be sigma by epsilon. The reason for that, what is the field strength at point P? Field strength at point P is given by, all will contribute E2 and E4. Sigma by 2 epsilon naught, sigma by 2 epsilon naught. You add up. And you know sigma, substitute here, Q by 4 pi R square epsilon naught. I think your physics teacher is correct. What is the field strength exactly? Just on the surface of a shell, Q by 4 pi epsilon naught. Am I right? We have derived all this. So who will actually contribute field at point P? These two, the charge present here and here. Together they'll contribute. Are you getting now? Okay, sir, this is totally cheating. You didn't say all these things. Yes, at that time, we were taking up of Gauss law. Now we have some better picture about Gauss law, field, everything. No, so this is a better way of thinking. The field at point P is not only due to this charge, it will also contributed by charge present on this opposite face. There's a meaning here. Why net field is 0? We'll draw a Gaussian surface. Net charge enclosed is 0. That's why field is 0. Okay, fine. Come for here. These two will be equal and opposite. So the resultant field inside the shell will be 0. Agreed. Okay, now shall we discuss electric pressure here also? The charge present at point 4, like a here, the charge present here, will it experience force due to 2? Can be, no, it can be. Then how it will be radially outward? Same diagram here in detail. Let me show only. Yeah, no. So here I'm going to assume I'll remove that point P. So many symbols. Let me assume again, as usual, a small element here. Now this element, so it's having a charge dq. Will it experience any force due to E2? Yes, it will be. We'll take some of this one. Yeah. df. df4, I'll write it. So what is df4 equal to? dq into E2. What is dq? Sigma into ds. What is E2? Sigma by 2 epsilon naught. And df4 by ds, what it should be equal to? The electric pressure. And what this electric pressure is doing, it will try to expand. So like that, the whole shell what happen will experience a radial outward force. Similarly, what we can assume? We can assume here some element. This element will experience force due to E3. The charge present at 1 will experience force due to E3. The same idea. Charge present at 4 will experience a field, will experience a force due to field produced by the charge at 1 or due to electric field E2. The same expression what I did, the applicable here also. This is called like electric pressure. So what is the impact of electric pressure on a conducting shell? It will try to expand. Is it happy, this shell? Charges shell, is it happy? No. Constantly electrostatic force is trying to expand. The elastic forces which are present inside will counterbalance it. I'll ask you that particular thing. Find the stress in this particular conducting shell, charged conducting shell. You should be in a better position. Okay, now let me give a one beautiful question. I want force exerted by one off on the other off. But the already idea is there, no? So let me take the same